What's up, Raiders? Just want to talk a little bit about as we transition to some algebra basics here. And this really kind of ties into some things that we've informally introduced already, but now we're just kind of shifting our focus to this. So remember, first and foremost, as we're going through any of this online learning, if you have any questions, like always, send me a message either directly in Odysseyware or you can contact me on the Remind app. All right, so when it comes to algebraically communicating, the first thing you need to be able to do is translate expressions and equations. Remember the difference between expression and equation. An equation is you're saying one thing actually equals another. So for example, if you just see something like a number plus 7, we're basically dealing with some unknown here that we'll traditionally represent with x or whatever letter variable you choose. So as soon as you see reference to a number, that basically means some unknown. Traditionally we call it x. So in this case here, a number plus 7. And obviously the word plus tells us what operation to do. So algebraically, we would say x plus 7. Now, next one, the difference between 12 and a number. Well, just like plus told us the operation from the last expression, here, difference tells us we know that means subtraction. And notice we once again see reference to a number. So the difference between 12 and a number could be 12 minus m. These are both expressions because it's a way of communicating something, but we're not actually saying what it equals, so it's not an equation. Well, now to take a look at an equation. This one's a little more elaborate, and it'll tie into a one-step equation that we'll be able to solve after setting it up. The product of 5 and a number is 20, so let's break this down. Well, just like we saw references to plus, difference, which told us the operation of addition and subtraction, well, product is multiplication. And once again, we see a reference to a number, some unknown. So the product of 5 and a number just means that would be something like 5a. And then as soon as you see is, mathematically that's equivalent to equals. So 5a equals 20. So now obviously we have a one-step equation here. Our goal is to figure out what this unknown number a is. So we have to undo everything that's happening to it. So ask yourself the question, all right, what's happening to this a? Well, this a is being multiplied by 5. So the way to undo that is you do the opposite or inverse operation. The opposite of multiplying by 5 is you divide by 5. And the golden rule, whatever you do to one side of the equation, you have to do to the other. So 5 divided by 5 is 1. That cancels out. That's why we did that. So 1a, or just a, equals 4. And we could circle back and check our work. 5 times 4 does in fact equal 20. So that's just kind of a little intro into how we can express things that we want to mathematically when we have an unknown value. Now let's take a look at a little more elaborate scenarios, two-step equations. And before we do that, it's good to just do a quick little reminder about order of operations. We use the phrase PEMDAS, and more frequently you'll see it written this way to reflect the fact that multiplication and division and addition and subtraction have sort of the same weight when we do order of operations. So anytime you have multiplication, division in a row, you just go left to right, regardless of which one comes first. So even if division comes before multiplication, if they're right in a row, go left to right. And then same thing with addition and subtraction. So if we know all the values we're dealing with, like with this expression here, we can just sort of identify, all right, what are the operations we have here? We have parentheses. We have multiplication right here. And then we have subtraction. So I use the analogy in class about when you get dressed in the morning, when you come home and you go to bed at night, you do the opposite. You get undressed. So the things that you put on last are what you take off first. So following that logic, that's going to be what we're going to dive into when we do an equation in a minute. But for right now, we have all our values, so we follow the order of operations exactly as we see it. The first thing we have is parentheses, so we'll do that first. 4 plus 2 is 6. So show how we simplified that parentheses and then carry everything else down so that we are only kind of showing one step at a time. So we took care of the parentheses. Now we have to take care of the fact that we have multiplication. Well, 6 times 3 is 18. Document that one step and then just carry down everything else. So now we took care of the fact that we had multiplication. And then finally, we have the subtraction. Take care of that. 18 minus 5 is 13. So that's a little refresher. So when it comes to actually solving an algebraic equation, we go in the reverse order of operations. So if we think about PEMDAS once again, now we're going to go in this order. So look at the variable we're trying to solve for, in this case, x. Ask yourself the question, what's happening to x? Because we have to undo all those operations. So x, how's it being combined with 5? Well, if there's no operation symbol between them, we know that's multiplication, and there's something added to it. So if we go in reverse order of operations, to undo this, to get x by itself, to isolate that variable, we go this way, we have to take care of the fact that the variable x has something added to it. So what's the opposite or inverse of adding 6? Subtract 6. And the golden rule, whatever you do to one side of the equation, you do to the other. And this is why this works. This cancels out, because if we added 6, but then immediately did the opposite, subtracting 6, it gets rid of it. It's like it didn't exist. So now we have 5x equals 10. So that took care of the fact that we had some addition to undo. Now we have to undo the fact that x is multiplied by something. If x is multiplied by 5, the opposite will divide by 5. And again, whatever you do to one side of the equation, do to the other. So we get x equals 2. And to check our work, we can substitute back in. Now that we know what x is, 5 times 2 is 10. 10 plus 6 does in fact equal 16. Okay, one more example. Let's list for ourselves the order of operations reminder. And because we're trying to solve for this unknown k, we have to undo all the operations that are happening to it. So we're going to go in reverse order of operations. So let's ask ourselves what's happening to the k. This fraction bar, remember, that really means division. And then k also has something subtracted from it. So going in reverse order of operations to undo this, what's the opposite or inverse of subtracting 4, and how do we make that go away? Add 4 to both sides of the equation. So if you subtract 4, but then you add 4, that cancels out. So the only thing remaining on the left side is k divided by 3 equals 6. So we took care of the fact that k had something subtracted from it. Now we have to take care of the fact that k is being divided by something. Well, what's the opposite of dividing by 3? Multiplying by 3. So do that to both sides of the equation. These 3's cancel out, because if we take k and multiply it by 3, but then divide it by 3, we're undoing that. So we end up with k equals 18. And again, we could check our work now that we know that k equals 18. If we go back to the original equation, 18 divided by 3 is 6. 6 minus 4 is 2, and that checks out. All right, if you have any questions, contact me on the Remind app. Raider Nation.